Good morning, ladies and gentlemen. Before we get started on Unit 9, Lesson 2, I'm going to go over the assignment that was posted on Google Classroom. The assignment that will be posted this week on Google Classroom, I will not go over until everyone has had a chance to turn it in, and there will be a due date. The due date will be a week from today. Today is currently March 30th. And before I get started, since it's been so long since I've seen you and you've seen me, I would like to try to do something with the video here, and that's to go all camera on you. So I'm going to go to the camera just so you can see my face. And you notice I'm coming into the screen now. I'm saying, hey, what's going on, everybody? Let's do pre-calculus. And you know that indeed that particular person is way better looking than I am. And I'm just testing this, and there we go. So let's go back to the video. Just wanted to basically see if I could do this with the video, and I can. So let's go back to the more important part, and let's talk about some trigonometry. And as I stated, I'm going to go over last week's assignment. So there were two problems. The problem number one was this creature right here. Number one was if k is between -1 and 0, right here, and the inverse sine of -k was j, to give a graphical representation of this. And then problem number two was if d was between 0 and pi/2, thinking that d is an angle, and the inverse cosine of c was equal to d, give a graphical representation of that as well. So let's begin working on number one. And I'm going to start off with the original statement that k is between -1 and 0. And if k is between -1 and 0, if I multiply everything, this whole equation, by -1, and you'll see why I'm going to do that in a minute, then -1 times -1 is 1. And when I multiply an inequality by a negative, the sign switches. That says 1, the less than becomes greater than. K times -1 is -k. 0 times -1 is still 0. That tells me right there that -k is going to be greater than 0. More importantly, -k is greater than 1. So -k is up here between 0 and 1. And now I'm going to take this part of that statement, and I'm going to sign both sides, and I'm going to say, hey, if this is true, if the inverse of -k is equal to j, well, wouldn't that imply then that the sine of j is -k? And indeed, it does imply that. And what do I know? Well, I know this -k is a positive number, and I know that sine outputs a number between -1 and 1. But in this case, -k is going to be positive, and that's because the original k was negative. So if I look at what I'm going to do here is just to create a line, try to get it from the center there, and that's going to be my terminal angle. And I'm going to denote this angle right here. I'll do it in the same color. This angle right here is j. The sine of j is -k, and I know that the sine outputs a y value, and that y value is going to be -k right there. So this is the graphical representation of number one. This is my angle right here, and this is my output -k. Okay, so now this other number two is pretty easy. D is going to be between 0 and pi/2. D is going to be an angle. Why do I know that D is an angle? Because if I take this statement right here, and that statement would certainly imply that C is equal to the cosine of D. So D is an angle. D is between 0 and pi/2. Let's sketch D here. Let's change the color of D. Let's go this time green for the angle D, for the terminal angle. Let's see. So I'm going to come up here just to keep it out of the busyness of the sine of j, I'm going to let that rascal right here, I'm going to let that angle be d. That angle right there is d. And I know that the cosine of d is going to be an x value on the unit circle. And that point right there is going to be c something. We don't care what the something is. So there's your graphical representation of number 1. This is your graphical representation of number 2. Most of you turned it in. I think several of you, I'm not going to be real stringent on this grading. However, down the road, these Google Classroom assignments where you have to take a picture and submit it, those probably will become quiz points. So let's go on and start talking about Unit 9, Lesson 2. In Unit 9, Lesson 2, if I skip to this particular slide here, we're talking about the formal definition of the inverse sine and inverse cosine, which is going to kind of flow from the informal definition, which was Unit 9, Lesson 1. So, and we're going to look at the formal definition of the inverse of f of x. This was back in, I believe, Unit 5 or Unit 6. This is the formal definition. Two functions are inverses. If you take the composite of the inverse and the function, and you get x, and you take the composite of the function and its inverse, you get x as well. That tells me that two functions are inverses of each other, this statement right here. So we're going to start this discussion about the formal definition of the inverse of sine of x, and we're going to let that guy be g of x. But before I go there, I'm going to go to a graphical representation, and I'm going to use the unit circle down the road. So I'm going to look at, and I'm going to start my discussion before I explain these two equations, if you will. I'm going to look at the graphical representation of the inverse sine. So I have the sine of x using the unit circle, of course. So I have this unit circle right here. Okay, this is a circle. That guy here is 1, 0. All the radii are 1. And if I remember correctly from Unit 9, Lesson 1, that the inverse sine is only going to exist if I restrict the domain of sine from negative pi over 2 to pi over 2. That allows sine to be a one-to-one function, and that allows the inverse sine to exist. And keep in mind, what is the range of this function right here? The range of this guy right here is going to be the range of f of x. We know the range of f of x is, or y is between 1 and 1, negative 1 and 1, and that's what we're saying here, that the y values on the unit circle are between negative 1 and 1. In the domain, I've restricted the domain of sine to be between negative pi over 2 and pi over 2. Well, this guy right here allows me to realize what the domain of inverse sine is. The domain of inverse sine is between negative 1 and 1, period. End of story. No restriction. That's the domain of inverse sine, period. Because that's the range of sine of x when I restrict the domain. An interesting point is, if I just look at the regular sine function without restricting the domain, the regular sine domain is all reals. But I'm going to restrict it to these values, these input values, so that it's 1-to-1. This is going to be very important as I talk about the formal definition of sine and inverse sine. So what I need to know here is that the domain of the inverse sine is between negative 1 and 1, period, end of story. Let's get back to these notes here. Okay, this is the formal definition of the inverse sine. Noting from our Unit 5 discussion, g of f of x, which is going to be the inverse sine of sine, is x, where x is between negative pi over 2 and pi over 2. Good deal. Good deal. And f of g of x is going to be the sine of inverse sine of x is equal to x when x is between negative 1 and 1. Good deal. Okay. So the sine of the inverse is x. The sine of the inverse of x is equal to x, where x is between -1 and 1. And this is also true. The inverse sine of x is equal to x, where x is between -pi/2 and pi/2. This is the part right here. This guy right here is going to get a little bit, I guess you could say the word challenging, if you will. This is not. This is not going to be challenging. Okay, so first of all, we're going to look at this sine of inverse sine. Sine of inverse sine of 0.7. All I need to check to see if this 0.7 is between -1 and 1, and it certainly is. So this guy here is 0.7. Done. Story over. Easy. Sine of inverse sine of -0.3 is -0.3. Is that between -1 and 1? Happy daggone New Year it is. Done. -0.3. What about this guy right here? Sine of inverse sine of 1.7 certainly is going to be 1.7. Whoa, 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 whoa. Hey, wait a minute. 1.7 is not between -1 and 1, so I made an error here. This guy here is not defined. And we will explain why it's not defined down below here. So this one here, let's go here. All I need to check then is negative for the sine of inverse sine of -0.5 is -0.5 between -1 and 1. It is, so this is simply equal to -0.5. And what I want to do at this point is which of the following expressions are not defined. This guy here is not defined, since 1.7 is not in the interval between -1 and 1. Okay? So, pretty straightforward. When I go sine of inverse sine, it's going to be pretty straightforward. Now let's talk about, well, and this is the part where I say it's very straightforward. Sine of inverse sine, very straightforward. This is easy peasy. It's equal to x, and all I have to do is check is x between -1 and 1. Okay, and why is that true? Why is that? That's true since the domain of this guy right here, which we're going to call the inverse sine, is only x such that x is between -1 and 1. If x is not between -1 and 1, this guy is not defined. G of x is not defined, so I'm taking the sine of something that's not defined. And that's exactly why this guy here was not defined. Okay? So now let's look at example 2. Example 2 is going to deal with this particular portion of our formal definition right here. It's going to deal with this. Why don't you scratch that out, you nut? It's going to deal with this particular portion right here. Okay? Inverse sine of sine. Okay? And what do we know? Well, the inverse sine of sine is x, where x is between -pi/2 and pi/2. All righty? So let's see here. Let's inverse sine of pi/6. Let's see here. Is pi/6 between -pi/2 and pi/2? Yes, it is. Oh, boy. This looks like it's going to be a pretty easy daggone lesson here, Lee. Let's try this guy right here. Inverse sine of sine of -pi/4. What about that? I need to check is -pi/4 between -pi/2 and pi/2. Oh, yes it is. So this is easy. Hey, this is pretty easy, Mr. Strassel. Let's do this. Let's just jump down here and do inverse sine of 0. Is 0 between, where the heck did you go? Is 0 between -pi/2 and pi/2? You betcha. So this guy here is 0. And uh-oh. Inverse sine is sine of 4/3 pi. Well, 4/3 pi, ladies and gentlemen, is not between negative pi over 2 and pi over 2. Sorry, it's not there. So, daggone it. So maybe this thing is undefined. Well, let me tell you, it is defined. And we're going to use a graphical representation to figure out what that actual value is. And here's what I'm going to do. I do know this. The domain of inverse sine is between -1 and 1. What I'm going to do to give a graphical representation to show you how to do this, first of all, this, come back, ooh, this guy right here is always defined. This is always defined. And I'm going to explain why it's always defined. This is not always defined. This sine of inverse sine is not always defined. That's only defined when the input is between -1 and 1. This rascal here is always defined. Why? Because guess what? Sine of A is always, no matter what the angle is, the sine of A is always between -1 and 1, and the domain of inverse sine is between -1 and 1. So this guy here is always going to be defined. So my question then to you is, how do I figure out what this is right here? Well, here's what I'm going to do. I'm going to go to 4/3 pi, and I'm going to sketch the sine of 4/3 pi. So let's do an angle. Let's do a terminal angle here. Doesn't matter what angle I'm on. And I'm going to go, what? 1/3, 2/3, 3/3, 4/3 is going to be about right there. So this is my 4/3 pi. That's my angle 4/3 pi. Hey, what is the output? What's the y value associated with sine of 4/3 pi? The y value of that is going to be negative square root of 3 over 2. True or false? That's going to be true. So really what I'm looking at, what's the inverse sine of negative square root of 3 over 2? What's that equal to? Because the sine of 4/3 pi is negative square root of 3 over 2. We're going to have to think about that a minute. Okay, so, and if I go back to my original discussion here, in order for inverse sine to exist, my angle has got to be between negative pi over 2 and pi over 2. It's got to be back here. It's got to be over here. So all I need to do for this particular example is to come up with an angle that has the same y value of this guy over here, 4/3 pi. Okay. So what angle would that be? This is what that angle would be. And I'm going to make this line now blue. It's going to be this guy right here. It's going to be that dude right here. Where this, it's not really. Let me pull that out of there. Let me get rid of him. I don't like him. I'm going to do another one. That's going to be more like it right there, Lee, just so it's symmetric. That dude right here, I don't know what that angle is, but it's going to have the same y value here. And what angle? The sine of what? If the angle is between negative pi over 2 and pi over 2, what angle is that going to be? Oh, you're digging dog daggone right. That angle is going to be negative pi over 3. So this is equal to negative pi over 3. And now do I check? Is negative pi over 3, ladies and gentlemen, is that between negative pi over 2? Oh my goodness. Is that between negative pi over 2 and pi over 2? Yes, indeed it is. So now, does it have, is the sine of negative pi over 3 the same as the sine of 4/3 pi? You bet. Why? It's because they have the same y value. And now I have an angle that's between negative pi over 2 and pi over 2. So this is negative pi over 3. You are going to be asked to do some graphical representations of these type of problems, and this is your graphical representation. A graphical representation, that is, on the unit circle. You could do this on the xy coordinate axes looking at the graph of sine, but we're going to limit our graphical representation of this on the unit circle. So I'm out at 20 minutes. I want to keep my videos at 20 minutes. I will continue with this tomorrow. The formal definition of cosine and inverse cosine, I'll limit that definition tomorrow. I will start that video tomorrow. Today, we're just going to talk about inverse sine and sine. And all I can tell you is you need to watch these videos. We're going to go kind of at a pretty easy going pace, but you need to be watching the videos. So I will tell you, ladies and gentlemen, oopsie. Ticker says goodbye.